song video for you guys. I'll put it on the website so you can show your friends.
Yeah, or our family.
Yeah,
if we don't
sure.
have friends.
My mom tried to tell me that math wasn't rad, so I can finally prove her wrong.
Very good. Math is rad.
Yeah, maybe if you have a rat.
That's right. I showed you the movie Rad. Have you rented it yet?
What's that?
You show us some rat. Oh, yeah.
Don't get me off track. This is not a very long lesson. I want to get off track, but I shouldn't. It's only a Monday.
No school.
Anyway.
It's a Wednesday, you goofy northern.
Wait, when's our test?
Friday. We'll have a quiz on this stuff on Friday.
Ooh.
Again, what happens here is that when we work with base E is that we're going to worry about exponent rules again. We're going to talk about three things today. We're going to talk about combining like terms with E, basically simplifying expressions. We're going to talk about how you can graph it. Just kind of briefly talk about graphing today. We're not going to spend a lot of time on that. We'll spend more time on that tomorrow. And then lastly, we're going to talk about how it works with continuously compounded interest problems. It's a very, very simplistic form of what you guys did last week with your principal and interest rates, compounding quarterly and semi-annually. It's an even easier formula to work with. So today we're going to talk about simplifying. Again, when you're worried about simplifying expressions, if they have the same base, you're multiplying with your exponents, what do you do to the exponents?
Add the exponents.
You add them. So e to the third times e to the fourth becomes e to the seventh. Very good. You treat it the same way as you would if it was an x, if it was the number 3. All these same exponent rules here still hold true. And the next one, I have 10e to the third power over 5e squared. Take care of your numbers first. What happens? 2
E over E.
2e
Yeah.
or not 2e.
For sure.
Oh, that's not
I
even a
remember the
matter.
first time I watched The Grinch.
Is that really a trivalent license?
And then the last one. This is where things get a little bit weird.
Yeah, this looks a little
Oops. In this case here, we have power to power. You agree?
yes.
Now, we have two things going on. We have power to power with this part, and then I have 3 squared. So when that happens, we have junk squared. We have to basically distribute that squared term to both parts. You get 3 squared, and then it's e to the negative 4x squared. 3 squared is easy. 9, thank you. Now, when it's power to power, what do you do with the exponents? You multiply. Careful, you're multiplying. This negative 4x is the exponent. It is the exponent. So all you do now is multiply negative 8x. And that's where it gets weird because you have that value of x tacked in there, and you want to think about, oh, I got to square it. But since this is raised, this is the exponent part here, this is the exponent, the power rules would be you multiply that. So it just became negative 8x. Okay? And now what am I going to do? Yeah, exactly. And now it's not happy, so it's 9 over e to the 8x. Again, the reason you do not square it, you're not squaring that value of x, is because that unknown, that variable, is part of the exponent. And the exponent rules means when you go power to power, you just multiply them together. Yeah?
Why doesn't the 9 go with it under?
Because it's 9 times that. Remember when we had stuff where it was 4x to the cubed squared, and if it was negative 3 here, it became 4 squared x to the negative 6, so it was 16 over x to the 6th. It's the same rule. The same thing applies. You treat it
If it was adding or subtracting, it would go with it, right?
yes, because then it is its own term. Okay. Then you really can't do anything with it. You're not going to be foiling these things out or anything like that. It's not anything like that at all. I just wanted to show you guys the generic setup. And that's usually where most people have their issues, is they forget when it's power to power, that variable is stuck up in the exponent. Okay? That's really all there is.
Wait, that's it?
Really?
Tooth for an arm.
No, I've only done one thing so far.
Yeah, we're done.
No, I mean like as far as the exponent rules. I mean the exponent rules are exponent rules. You'll have a bunch of them to try tonight. It's not like it's going to take that long. Yeah.
I count one as 5 days.
Extracurricular activities.
The scary stuff.
No.
Growth or decay.
Don't write this down.
Don't write this down.
We've already done forgetting what it's called.
Don't write this down.
Can we
Oh, it'll break your
What happens here? What happens now is we have this.
Can we write that down?
Can we erase
Probably.
it up?
Oh, meaning don't write the paragraph, but write this?
Right.
Oh.
Oh.
When we talk about graphing these, in order to tell whether or not it's going to be exponential growth or exponential decay problem, is that if r is greater than 0, it's growth. If r is less than 0, it's a decay. For right now, that's all we need to really worry ourselves about is how to set these things up, is whether it's going to be a growth or a decay problem. If the r value is positive, it's growth. If the r value is negative, it's decay. And what am I not taking away from you?
Calculator.
So do you really need to know exactly how this is going to look?
Maybe.
It's not as clean of graphing as the stuff we've done with when it's just straight growth or decay. When you bring in the e value, since that value of e is some decimal, it's very difficult to find nice, clean, ordered pairs that work. The only thing you can normally find with e's is going to be your y-intercept. Just like we did here, your y-intercept was always your value of a. Same idea here. Your y-intercept is going to be your value of a. You'll have a starting asymptote at y equals 0. And then if there's an h and a k, we can shift these things around. So we'll worry about more of the graphing tomorrow. I just wanted to show you real briefly of what that does look like before we talk about how you work with these in word problems. If I look at this, I don't know if you can see that very well. It's y equals 2e to the 0.75 x. And I want to show you guys how you use your calculator to set this up. First thing I'm going to ask, is this going to be a growth or a decay? It's growth, because it's positive. The r value is positive. Everybody agree? Okay, that's how tough it is to decide whether or not it's growth or decay, if it's positive or negative in the exponent. All right. Now, when I go to graph this in my calculator, y equals, clear it out, it was 2. Now there's two, on your calculator, there's 2 different buttons for e. One of them is at second ln.
Oh.
Second ln stands, the ln stands for natural log. I know you probably want to say NL.
Log natural.
But
Alana was talking something in that FPLA today, and he was like talking about log, and I don't know.
We didn't know what it was. We hadn't been in this class.
He was just like, oh, it's going to get really easy. I have a trick to show you. It was really weird.
And we learned a trick that we don't know what to do with
Yeah.
because we hadn't been in this class.
She was just straight.
Humorous, I suppose. However you want to take it. I guess however you want to leave it. It's up to you. That's the story.
let's show me what he showed you guys. Anyway, notice how when you press that one, it automatically raises an exponent. It's blinking for the exponent.
What'd you get? Where's
Second
LN?
natural log, ln. It stands
Oh, I
for
see.
log of the natural base. That's why they wrote it as ln, not natural log. So that automatically is just sending you up to the exponent, so you hit 0.75x. If you use the other E button, I think the other E button is underneath, is with the division symbol, then it's just the actual value. You'd have to use the caret to get to the exponent. So this is just a little shorter to work with. They both get you in the same place. Now again, hit the graph button and you should see something like this. I'm hoping, right?
Maybe if I was you, yes.
Everybody, you see a curve like that?
Yeah.
Look at your table real quick. When you look at your table, when your value of x is 0, what's your y value?
2.
Convenient, isn't it?
Convenient.
Because if x is 0, what's 0 times 0.75?
2. No.
0. What's e to the 0?
2
1.
times
Times 2 is, eventually you'll get it right. Again, when it's non-shifted, there's no h and there's no k. When your y-intercept is going to be at your value of a. Just like we've done in the past. Okay? Now, when you look at your table, you're gonna start to see you've got a whole bunch of nasty decimals then.
Yeah, those are really.
Okay, at 1 it's what? 4?
4.23.
Here-ish?
It's E.
It's E.
Drawn and
That's about it. And like I said, when we're graphing it with E, it's not so much can you make the graphs, because it's not as easy to plot normal points, if you will, regular integer values, as it is when you have regular graphing with exponential growth or exponential decay. In this instance, it's just a little bit more fudged, if you will. Okay? So from these things, just to start with, can we just tell if it's growth or decay?
Yeah.
Does that make sense?
What about the domain?
Domain and range? All right, well, domain, what's your domain?
X is greater than 0. Y is greater than 2.
Y is greater than 0, so that is going to be your domain or your range?
Range.
Range. So what's your domain?
Y is also greater than.
What are your x values?
X is all real numbers.
All real. Yeah. And it's going to be set up like that. We'll talk more about graphs tomorrow when we look a bit further into it. The graphing of this stuff is pretty simple.
So it's pretty much the same as what we've been doing. Like
Yes.
Very similar.
So,
Yeah.
so are these shifted, the graphs?
We will. We're going to worry about shifting them tomorrow.
So is this the parent function? Okay.
We'll worry about more of the graphing tomorrow. What I decided, since this 8.3 is a little bit less material than some of the other ones, I wanted to put a little buffer in as far as our time is concerned. And so I figured by putting the quiz on Friday, letting you guys have time to go through this up and ask any other questions from 8.1 and 8.2 tomorrow afternoon before we do the quiz on Friday. Then.
Is this shift the same?
The same. It'll be the same. Yeah, it's very, very easy. Yes, sir.
You're talking about the blinking up there. I said that you're blinking. Is it kind of tight, you know? And he's like, oh, no, it's just up on the E. And you would have to be there. You have to be on Mount Rushmore. And he's like, hey, never seen that movie?
Which one?
Do you want to draw tights?
Men in Tights? No,
I haven't brought it.
I know it. I can't remember. It's got to been a long time. Now I know how you guys feel when now you know how I feel when I say bad jokes, and you kind of look at me like,
Yeah.
why are you
you
smoking
saying
crack
that
this
was-
bird?
We've never said fuck crack.
Anyway, so what happens now is that if you remember last week, we were talking about compounding interest problems. When we're talking about compound interest problems, we're talking about things where they're compounding quarterly, semi-annually, things like that. That's where we're getting those n values. The value of n tells you how many times things were compounding. What's going to change a little bit today is that we get an easier equation to use when they say that your interest is compounding continuously. Compounding continuously mirrors the idea of daily compounding, where the n value would have been 365. It mirrors it. Bless you. So what we do here in this case is that we're going to have A equals per. So we're working with dander shampoo today. Dander shampoo. Dander shampoo.
Get off my stuff. What's pert?
I use it a lot.
I use dog shit.
Why would you
Oh, I
use
get it.
shampoo?
Pert is a shampoo.
But you
That's a
should
shampoo
wear-
for real?
Shampoo.
Yeah, do you use shampoo?
You
No,
mean you
no,
lotion your scalp?
Wait, do you use shampoo?
Yes.
Why don't you not use like what?
You use dog food. Maybe it's me.
You save more money on that one.
Anyway, again, this value of P is your principal.
No, I need to know the answer.
R is your percent as a decimal. And T is your time. All right. This value E is the button on your calculator. It simplifies the idea of using that 1 plus R over N for only if it states it's compounding continuously. If it's compounding continuously, you use PERT.
What's that?
As a decimal.
Oh,
Your over amount will be your principal, your initial amount, e to the rate times time. So again, in this case here, your rate is going to be some percentage. The time is time in years or however many things are left. And it's just a matter of really just putting stuff in the calculator.
Yeah, it's pretty simple.
For example, what's that? I think I know that's yours. in this case here, if I'm going to deposit $1,000 into an account that pays 8% continuously compounding interest, how much money would I have after a year? So, rather simply, again, you know how much you're starting with. You're starting with $1,000 as your principal. You know it's paying you 8%, so what's your rate as a decimal? 1.08. So my overall amount is going to be 1,000 e to the 0.08. And I want to talk about just 1 year, so it's times 1. What's that?
I just
Oh, you need water.
Wait, so E is percent of gas?
What's that?
So it says,
No. R is your percent as a decimal. You always put R as your percent as a decimal.
I didn't know.
Okay. E is the button on your calculator. You can type that straight in your calculator, it's going to spit out your answer. What do you get?
The answer, $1,083.29.
He's right. Now, if you had to work opposite with this, let's say you had to figure out how much you're going to have at the end, what would you use? Yeah, use your y equals again. Use your y equals. All right? Wow.
Did you hear her?
Yeah. She like tried to like take my eyeball out.
You have eyes in the back of your head?
Yeah.
I just heard
That's
swearing.
impressive.
Yeah, I just heard bad language.
I didn't hear it. All I saw was her.
No,
She was scowling.
Okay. Let's try another one like this. Again, sometimes they use it a little bit differently. Sometimes they use it as an inform of a model. Sometimes they use this in form of modeling as well. Just like we did in the past, if it asks you to graph one of these weird looking models, are you going to? No. You're going to use your y equals, and you're going to find the data yourself. So in this case here, they're talking about fish and wildlife, endangered species between 72 and 98. It is modeled by the function s equals 119.6 e to the 0.0917 t. You do. T. And t is the number of years since 1992. So the first question is, what was the number of endangered species in 72? What's your value of t going to be?
1.
0. That's the initial.
Yeah, but what if it's like?
Wait, what? What is the number of endangered species?
What's your initial amount?
119.6.
There you go.
I was just,
Now I know. Can you have 0.6 endangered species? Do you have 2/3 of a cat?
Well,
Yes.
yeah.
Yeah.
You can measure
Stop.
becoming endangered.
Anyway.
Like a couple of legs.
Missing a tail and a leg? Yeah, no.
I saw us missing.
Anyway,
My dog.
could you say you basically your initial amount be 119 animals, right?
I say 120.
Is this going to be a growth or a decay? What is it? Why? The R value is positive. Okay. So again, the initial amount, 119 animals. I'm not going to graph it because that's just nasty to try to graph that out. But if I use my graphing calculator, I can figure out when was there 1,000. How many years did it take to get to 1,000? So 119. Again, when you're doing these things in your calculator, the biggest mistake that people might make is they might type in the wrong value. I mean, you don't even see what the graph is, but if you go right to your table, you can start looking around there. What's that? E, second natural law, the LN button. And then you just scroll through, you're looking for 1,000. And that's how many years you have to add on.
If it's between, you go up or down?
You just round up, yeah.
Alright,
Unless you want to say it's June.
24.
Jay, Richie.
I just round up, say 24 years after 72, so that'd be what, 96? Where were the Olympics in 96?
Atlanta.
Atlanta, very good.
Vancouver.
I went there.
For my mom.
Mr. Murphy, who are you rooting for in the Olympics this year?
The Soviets.
Soviets.
Richie.
Soviets, Russia, we don't celebrate them.
Did you know Richie's Russian, Mr. Murphy?
Yeah, Richie's straight.
Yeah, between 23 24 years.
Okay.
All right.
Richie was born in Russia.
Is this scary?
Maybe if you're born.
You'll be fine. We'll give you some problems too. We'll do some more graphic junk tomorrow.
Dude, I don't want to hear that gross. Richie did that. That's Do we have to graph this, Richie?
No grabbing today.
No, not today. We'll grab stuff tomorrow.
Yes, I guess with mine.
Yeah, I love guessing mine.
I'm about to say, no, I only have one part. Just throwing the hard stuff. Oh my goodness.
Real fast. Let me explain to you what you are looking at here. It is not that fast. Guys, bless you. Hold on. This first grouping, it's simplifying the expressions using your exponent rules. This second group, I know that's scary.
12.
Is it growth or is it decay?
Oh, that's all it asks?
All of that.
Oh, and you got to know.
And then the last couple are some perk problems as far as the moderating stuff at the very end.
Perk?
Okay?
Perks.
Okay? You guys it shouldn't take you very long to get through this stuff at all.
5 minutes.
Oh, it would take more than 10. Okay?
I'm going to do it with Mr. Murphy. This week at
I don't know. Real fast, I do want to bring this up. Today is
TM.